Hi, I'm David Foster, and yeah, welcome to the Typing Summit. So I thought it might be useful to present a roundup of some new typing features that are in the current version of Python that we have right now, Python 3.10, and the new version of Python that's coming up later this year, Python 3.11. So just going to go through them somewhat quickly. First, I guess I should introduce myself a little bit further. Again, David Foster, contributor to MyPy and especially TypeDict. When I'm not doing open source, I am Chief Technology Officer at TechSmart, where we are bringing world-class computer science education to the next generation of K through 12 students and teachers. So getting kids excited about coding. And you can find me online at these places. So a couple of years ago, or not just last year actually, just in early 2021, I wrote an article that was proclaiming that Python was in the middle of a type checking renaissance because we've had so many PEPs recently that are introducing new typing related features. And this year, 2022, is no exception to that. So as mentioned, I am hoping to, in this talk, to go through some of the specific features that are in both the current version of Python and the new version of Python 3.11 that will be released later this year. So let's talk about where we are right now with Python 3.10. We've got 4 typing-related PEPs here, a couple that are introducing new kinds of types, so ParamSpec and TypeGuard. There's other types of notation that's been added, and one theme that I think is recurring is eliminating imports required from the typing module itself, which makes typing annotations more easy to use. So just to go through some of these briefly, I'll show an example of code before the introduction of the feature and what you can do after the feature. In 3.10, the first thing I have up is ParamSpec, which is particularly useful for annotating decorators. Before it was difficult to annotate the types of parameters that you put into a callable in particular. The ... that I have here is actually what you write, ... it's not a placeholder. The type checker isn't able to understand in this case that there's an association between the input callables parameters and the output callables parameters. But if you introduce a ParamSpec, you can use that as a placeholder for any set of parameters. And so then it becomes possible to have this decorator nicely typed, which has been a problem for some time. So can do that now. Moving on, TypeGuard. So this is particularly common in JavaScript, but it also happens in Python where you have a function that is used to check whether something is of a particular property that a type checker can't figure out. So in this case, I have an example of a function that checks whether something is a list of strings. So we have a function that just returns a bool here, which is okay, but it would be nice that if you called this function and it returned true, that a type checker could narrow the type of the thing that you pass to this function to be a str of list. And with TypeGuard, you can do that. If you set the return type to TypeGuard list of str, you return true, narrowing happens. Beautiful. Moving on, TypeAlias. So in Python, we've had the ability to define type aliases for a long time implicitly by assigning effectively a type expression to a variable, and then that is interpreted by type checkers as a type alias. However, there are cases where you want to be explicit that that's actually what you're doing, and at the moment, if you do something very similar, which is you assign a stringified type expression to a variable, a type checker will not be able to figure out that you actually wanted to make a type alias there. So now with type alias, you can make the otherwise implicit aliases explicit, and you can now use forward references for stringified references, which is useful. So That's kind of cool. Next up, one of my favorites is the ability to write union types and optional types, which is a variable or the constant none, using the pipe operator. So this eliminates a few typing imports from the typing module. So no more import from typing module, and you don't have to type as much either, because instead of writing union, you can use a pipe. Instead of writing optional, you can just say pipe none. Works great, is explicit. So that's Python 3.10. That's what we have access to today in the final release. There is also Python 3.11, which is just about to enter its first beta, I believe, either today or tomorrow. And I heard a clarification?
Next week.
Next week, okay, 3.10 beta 1 next week. So these types of types are now available. So we have, let's see, 1, 2, 3, 4, 5 PEPs here, so I'll just briefly go through those as well. So let's talk about LiteralString. So there are a number of APIs that expect some kind of fixed format string, a command string of some kind. And in the documentation for such APIs, they may say that you really should just use like a string literal, but there's no way for it to actually enforce that, because that's just in the documentation. So common cases, you have something that's running like a SQL command, or as a second example I'll show you in a moment, if you're writing a format string to a logging function. So right now there's no way to tell a type checker that this string that you're passing in should be a literal. But with a literal string, you can actually annotate it that there should be specifically a literal passed in. And if you don't do that, a type checker will tell you that that's no good. So that's pretty cool. So you can avoid command injection for people who use APIs with literal string who also are running type checkers on their code base. And for many large code bases, this is already done. So as mentioned, there's a second example here of formatting strings, which is another type of command string. And in particular, we had an issue recently with log4j, where you had some unexpected use of things in command strings. And that would be harder to exploit if you had something like this used to type annotate a function expecting a format string. So that's literal string. TypeVarTuple. So this is interesting. So there are a couple of libraries that define array-like classes. So NumPy's ND array class, TensorFlow's tensor class. There are many cases where the data inside these has either a particular set of expected data types or dimensions. And right now, the only way that you can only put that information in comments and documentation. It's not enforceable automatically in any way. So here I've just got a comment here that's saying like this is an image and it happens to have a height and width as its dimensions here. But with TypeVarTuple, you can define array types that you can just give generic properties for each of either the dimensions or the data types or whatever property that you think is useful to be enforced as consistent. So here we can actually just say height and width explicitly. And because they're new types, it won't allow you to like mix them up. Like instead of height width, maybe you put width height. Easy to get it mixed up if you have column-based ordering versus row-based ordering. So that's TypeVarTuple. Self. So there are a number of APIs that are written in a so-called fluent style, where you have methods that on a class that return the same instance of that class after they finish, so they return self at the end. Before it was possible, although rather cumbersome and verbose, to annotate the return type of such methods to describe to a type checker that it's actually still returning self. You can do that with this fancy thing with a type var. Well, now you can just do it directly. So if a function returns the value self, you can also say that in its signature that returns the type of self, and it will do all of that magic for you, which is great. Data class transform. So this one's interesting. So there are a number of libraries that define things like data class, model classes of various kinds. So you have adders is an old one, Pydantic is a newer one, but there are many of these libraries that define classes that act like the built-in data class. And right now, in order for a type checker to support these various libraries, there has to be a special plugin that is written for each library and each type checker. So a lot of times these plugins simply don't get written. Well, now there's a way for library authors who are making something like a Pydantic model or an adders base model to specify on those sort of meta models effectively. They can add this data class transform decorator, which tells type checkers that it acts like a data class. And so then you don't need the definer of the meta model doesn't need to start writing a series of plugins for all the type checkers. So that's great. And last but not least, there is an extension to the existing type-to-dict, type-to-dictionaries data type. Previously, it was possible to define a type-to-dict, which is a dictionary with a set of a particular expected keys that have expected values, very common in JSON. It was possible to define a type-to-dict where some of the keys are either required and some of them where they are not required. You had to do this weird hack where you had one type-to-dict inheriting from another type-to-dict in order to mark some keys as required or as not required. Well, now you can just mark it directly. So very common is you have a lot of keys that are required and a few that are not required. So much, much simpler to write. So that is what I've got. If you're looking for more information for example, a list of typing related PEPs, I've assembled an updated list in that blog post, Python's type checking renaissance. If you search for that, you will find that list of typing related PEPs, and you can get the PEP links there as well. Thanks for listening, folks.